I was working on this project it's called, the Learning Everything project, and I basically was going to make a blog about it, and I was going to learn many different fields that I was interested in, and then write articles on what I've learned. So it would be learning everything and then also sharing what I have learned. And, I thought that maybe some things would be better explained in a YouTube video. So I also made a YouTube channel called Learning Everything, but in the end, like I haven't really uploaded much and I haven't even written much. So I'm going to change that from now on, and I'm going to do what actually is the easiest thing. So I thought that because the blog and the channel, like this project is just sharing all of this in public, is in part to basically motivate me to actually learn to make this project real and not just a personal project, personal goal that I would just think is not important, is not that important, and I will just forget about it, or it will get sidelines. I wanted to make it a focus. So that's why I decided to make the blog and the YouTube channel. So I'm thinking that maybe, recording while I am actually learning would be better because I actually like recording things, but because I have basically made it like I have to actually study first, and then I have to condense everything that I've studied, and then I'm gonna make a video on that, and then I'm gonna upload, or like I'm gonna write an article on that, and then I'm gonna publish that article, and that is just too much. Like that is too much work, and it's not happening, and I don't end up learning anything, and I don't end up writing anything or recording anything. So it's not like the whole process is too much. It requires a lot of things to be done beforehand to even get to the recording part. So I thought, I'm just gonna record while I am studying, and then I'm gonna edit it and then upload it or something like that. I don't think, raw logs of me just reading a book or watching lectures would be that interesting. So, I will edit it, shorten it down, and try to make it like a learning resource, so that it's actually helpful for other people, for people like who's watching this video, hopefully. And so, I'm starting with, cognitive neuroscience. And actually, I'm not exactly sure if cognitive neuroscience is the right field. And like, if you've read my articles, and you know that I write about ADHD, or at least I'm trying to write about it, and it's mostly just AI writing about it. But that I have ADHD, and I also want to learn about ADHD and like what's going on in an ADHD brain, and why does it, like what are executive functions, and why are they impaired in ADHD, and what does that even mean for someone who has ADHD, like what kind of problems is that going to cause, and all of that. So I'm interested in that. And, because of that, like I'm interested in also maybe like psychiatric conditions, and, like why psychosis happens, or, like about attention, and I don't know, like how we learn things or whatever. Like basically just how the brain actually does all of these things. How does it actually make us be able to, focus on something, manage time, and all of that stuff. Like, I want to learn that, but also like I am interested in like I don't know what exactly I'm interested in. That's like one problem. I know some stuff from here and there, like some stuff from linguistics and some from maybe like psychology and maybe a little bit of biology and all of that. But like I haven't really formally studied it, and I don't know. There's so many fields. Like there is cognitive neuroscience, there's cognitive psychology, there's like there is, let's say, I don't know, computational neuroscience and like other fields. And basically I'm doing a degree in a field, basically machine learning or data science. So I've seen like I can basically go into like computational neuroscience and maybe even cognitive science if like the program is taking people without background in like uh, science stuff, psychology, or like I can go into cognitive neuroscience if they're okay with like people not knowing neuroscience basics or not having any uh, like college courses, in neuroscience and all of that. So I'm also thinking of, what I could go into later for, masters and all of that. But, I was thinking like computational neuroscience would be fun. But the thing is, these fields are really specific. They do, I was taking some course on computational neuroscience on Coursera, and it was, I don't know, about modeling neurons or something. And I think, I didn't have the background to actually be able to understand those lectures. So it seems that these basically like maybe because I don't know what these fields are actually doing, what am I like if I actually go into computational neuroscience or some other field, then like what would I actually study, what would I actually work on? I want to know all of that. And also like learning about even machine learning and uh, like how LLM is working and all of that, like and we know that all of this terminology, attention, all of that comes in like ML and LLM context. So anyway, it's like there is some kind of back and forth between these fields or something. Anyway, so I just want to look into it and we'll see from there. There is motivation to learn, but the thing is I'm not sure. So anyway, I asked ChatGPT. Basically, I wrote about something like that. What if really want to know about the field itself? Maybe I meant, what if I really want to know about the field itself? Like there are too many neuroscience and ML related fields, and I am doing it as a science degree that will go into ML and DL, so machine learning and deep learning at the end. I want to know whether I can know what civilization knows till now about the brain and psychology and psychiatry, etc. Also want to understand disorders, mostly ADHD and schizophrenia. I want to learn the chemical side and physiological side, but also the intelligence and like the cognitive side and philosophy side, like how categorization happens. Okay, and we know that having a word for something is needed to really conceptualize a thing, like people being able to distinguish a color better if they have a word for it in their language. And also I need to know what fields I can go into and whether I would like those fields or not. So something like that I wrote, and ChatGPT is saying that what you're describing is not just neuroscience, it's an intersection of all of these fields. So like cognitive neuroscience, psychiatry, computational neuroscience, psychology, philosophy of mind, linguistics, AI, ML, cognitive science, psychopharmacology, systems biology, and a bit of anthropology and sociology too. And because I asked my chat GPT to be funny and witty, so it wrote this, which is why the field can feel like someone dumped 12 partially connected maps on the floor and said, good luck, consciousness monkey. But good news is your background in data science is actually extremely compatible with modern brain science, because contemporary neuroscience increasingly runs on statistics, signal processing, ML modeling, dynamical systems, network analysis, Bayesian methods, embeddings, representations, computational modeling, neuroimaging analysis, The stereotype of neuroscience as a guy poking rat brain with electrode in basement is now only one branch, and there are also people basically doing applied math on cognition all day. So anyway, it basically says something like, so basically, like, it gave me some idea about, some different fields. So cognitive neuroscience is, this is how mental processes emerge from brain systems. Topics it covers is memory, attention, language, perception, executive function, emotion, decision making, consciousness. The methods is fMRI, EEG, MEG, later studies, behavioral experiments, computational models. This sounds very close to your interests, especially because you mentioned categorization, language shaping thought, cognition, intelligent conceptualization. That's classic cognitive science, cognitive neuroscience territory. So yeah, like I do want to know more about like attention, perception, executive function, because I think these are all important in understanding ADHD itself. So this language shaping thought, definitely conceptualization, definitely interested in that. So yeah, cognitive neuroscience is something that I would look into, that I would like to study. Then we have computational neuroscience, and it says this is mathematically intense. It asks, can we model brains computationally? Topics: neural coding, learning, dynamical systems, predictive processing. Predictive processing, neural networks, reinforcement learning, Bayesian brain hypotheses. So it has some ML related concepts. Okay, so this has neural networks, reinforcement learning, Bayesian brain hypotheses. So this field overlaps heavily with ML. A lot of ML concepts came from neuroscience. Historically, neural nets, attention, reinforcement learning, Hebbian learning, and now neuroscience borrows back from ML. It's a giant intellectual recycling ecosystem, like crows stealing shiny objects from each other. If you like math, abstraction, representation learning, emergent behavior, intelligence itself, then computational neuroscience may hit exactly the right part of your brain. So I'm not sure about math, because like I do like math, but only when I can understand it. So if it's like if it's too tedious, or maybe like it's really difficult to understand, that it takes me really long to get it, I don't think I would enjoy it. But I liked linear algebra and basically the math that we have to study for machine learning, and even statistics. Even though I don't think I am, like, I would definitely have to study statistics. I don't think that I understood much, at least not like I did enough to pass the exams, but I don't think I really got I really understood everything. So anyway, but yeah, representation learning, emergent behavior. Sure, like I did look into emergent behavior, all of that. So I'm interested in that. And then this is psychiatry. This is disorders of thought, mood, perception, behavior, and cognition. But psychiatry is complicated because it exists at the intersection of biology, society, institutions, pharmaceuticals, culture, economics, classification systems. This matters especially for ADHD, schizophrenia, autism, personality disorders. Psychiatry is not just discovering disease, it is also deciding what counts as dysfunction, which is why philosophy becomes unavoidable. So, I mean, like, I am more interested in like how psychiatry is like a mix of all of these than like reading actual psychiatry books, maybe. But I would need to read it. Anyway, so this is also interesting. ADHD and schizophrenia specifically, so we can study these, I guess. Cognition, neurochemistry, attention, salience, prediction, executive function, social structure, language, identity. And for ADHD, you can study it through dopamine systems, executive function, working memory, motivation, reward prediction, attentional regulation, temporal processing, but also socially, school systems, labor expectations, industrial time, discipline, productivity culture. Yeah, so definitely all of this I'm interested in because it's just learning about these two things. And yeah, labor expectations, industrial time, discipline, productivity culture is obviously important for ADHD. A lot of disorder discussions become political fast because societies reward certain cognitive styles and punish others. Schizophrenia, this one touches almost every deep question in neuroscience. It involves dopamine dysregulation, salience attribution, predictive processing, language, selfhood, hallucinations, reality modeling, cognition, genetics, social stress, trauma development. Some theories frame schizophrenia partly as a disorder of prediction and meaning assignment. Okay, you start asking, how does the brain construct reality? What distinguishes perception from inference? What is the self? Why does language stabilize thought? What is belief? Okay, I think this is also, all of these questions are interesting and we would definitely like to learn these. The words shape thought thing, you're touching linguistics, cognitive science, philosophy of language. The color example relates to linguistic relativity, often associated with Edward Sapir and Benjamin Lee Whorf. Modern view, language really does not imprison thought completely, but it absolutely influences categorization, memory, salience, discrimination, conceptual structure. This is now studied experimentally in cognitive science. You may love cognitive science if this interests you. So it has this table, cognitive neuroscience. Okay, so cognitive science is, it says interdisciplinary theory of mind. The thing is, I don't want to go like really deep into psychology without kind of like I want to ground myself in the actual science, not just like just thinking about like creating conceptual understanding. I think that, grounding something in more like how do we know things, how do we know something because of like maybe certain experiment and, that result, and like how do we actually, like, how did we actually come to certain theory? Like, anyway, like I don't want to go into all these like really thinking stuff where people just make theories because they are internally coherent and they explain things, which is good, but like I also want to ground it in like evidence, kind of what evidence actually proves that. And like, anyway, so yeah, not purely cognitive science. I'm pretty sure cognitive science, I know that it talks about attention and there's a lot of research, where they actually do experiments and all of that. So I know that's probably not like that, but anyway, just saying. So yeah, like I'm definitely interested in psycholinguistics. Not sure. Yeah, philosophy of mind. I think it would be really interesting thinking about uh, computational psychiatry. Maybe this would be interesting. I don't know. Neuro AI. I am not sure about that. So like I am definitely into like cognitive neuroscience and cognitive science, computational psychiatry, philosophy of mind, psycholinguistics, language and thought, neuropsychology, brain damage and cognition, and systems neuroscience. I'm not sure about it, but this is where we're probably going to cover all of that, how emergence happen, all that. And basically, I haven't studied any of it. Just maybe watched a video or something. Anyway, so I don't know much. That's the whole point. Like I'm gonna learn. So it gave me a very good learning path for me and gave me all of these books that I can read. But I asked it like books that are kind of serious. So it gave me books that they're not textbooks, but they are also like like books written by major researchers, books widely used in courses, books respected across disciplines rather than just best-selling top neuro. So yeah, like I would like to read these books, but also they should be accessible. Like they should not be really difficult to read. Yeah, I should be able to, read it. So I found like it says, cognitive science and introduction to the science of mind. It covers all of that. So I have this book now, and I don't have this one, but I have like this MIT Encyclopedia of the Cognitive Sciences, and I also got this neuroscience book. Uh, yeah, and yeah, so none of these, maybe like later. I also have the Surfing Uncertainty book. So I'm just gonna start with this book, as this is, yeah, Cognitive Science and Introduction to the Study of Mind. And it seems like a good book. So we can start reading it to get an understanding of what this field is about. Okay, so it's like it has these different approaches, philosophical approach, psychological approach, probably, to understand the mind. There are different approaches to understand it. Okay, and yeah, and in the first chapter, it would actually explain what all of you mean, probably. So we're gonna read this. Yeah, this is the cover. Cognitive Science, written by these people. Anyway, and yeah, so I wasn't like, I have all of these books. Okay, let's just close this. And yeah, I'm supposed to make notes, and I don't know how to make notes in like this Obsidian and like connect them, especially because there are too many notes now in it. Okay, and I also found like, MIT OpenCourseWare, and there are like different, we can find courses here for free. Some of them have videos, some of them don't. And they're also open textbooks, so we can use it later. And I also found, yeah, I was going to maybe look into it. This is, discrete math going to help me. And I also found this, so something CBMM, MIT Edu, something like that. And it has like lecture series all related to, neuroscience and brain stuff. So yeah, I think became interested in learning about like cognitive, neuroscience and stuff, because I watched her, like a course by her, and it was like the human brain. Let me just show you. Human brain, MIT. Okay, and yeah, so this series by her, and yeah, like I watched like many of the videos I did finish, but some of them I didn't. And this is probably what actually introduced me to all of this, and it was really good. The lectures are really good. And I think they go over like everything instead of just, okay, anyway, this is like a maybe cognitive neuroscience. Okay, maybe it's not the cognitive. Yeah, so it says this course surveys the core perceptual and cognitive abilities of the human mind and explores how they're implemented in the brain. So yeah, so I watched that, and this is probably what kind of introduced me to this whole field and made me interested in what I was talking about to ChatGPT anyway. And I also found this kind of some course on like machine learning. Yeah, it has lectures. There is the lecture series. So this is just machine learning stuff. Anyway, we're gonna close it. And yeah, so I was watching this computational analysis methods and issues in human cognitive neuroscience, like this talk. And I think because of the, like, I found this and started watching it, and suddenly I was like, I was doing this learning everything project, and I was going to learn things, and I was going to learn neuroscience, but I stopped because I was busy with college and all of that. So that's why I did all of this, like went to ChatGPT, that I'm gonna learn, and basically like recording this video. So this is what happened. Mm, yeah, before that I was trying to watch this, so like categorization, that's where the word is coming from. Anyway, so I'm just gonna actually watch this video. And his story is also pretty interesting because, he started college, like he was doing a physics degree, and then, he switched because he didn't actually like, doing the research that they were like he found that he wasn't really interested in physics. Then he became interested in, neuroscience stuff, I guess. And then he went into this field. So it's like he wasn't like he didn't start undergraduate degree like with this field in mind, but he still went there. So it's kind of like maybe, we can always can figure out if we are interested in some other field and kind of switch, hopefully. So maybe that'll happen with me.
Or fMRI. And this is actually the magnet, an old magnet. This is the 4T, 4 Tesla scanner at Berkeley that's no longer in operation. They've closed it down. They now have a 3 Tesla scanner. Scanners are rated basically by the strength of the magnetic field, and that affects the quality of the signal that you get. And the image on the right is an image activation map in a group of people. So in fMRI analyses, you have really good spatial resolution. That's limited to maybe 2 or 3 millimeters on a side throughout the entire brain. But the temporal resolution is awful because fMRI is actually measuring blood flow. And so the brain activates a certain region and uses up a little bit more blood. And then a few seconds later, you get a rebound as more blood comes in to fill the missing blood need. This is a very low-level type of explanation, but this takes a few seconds. And so you know exactly where something is happening, but you have no idea when it happened, right? And again, using the alien computer analogy, this is like being able to you can really, really precisely measure the electrical flow throughout different components in the system.
So he's basically explaining that, some of the tools that we use to do neuroscience, I guess. And so, you know what, I'm just gonna start reading this book because, yeah, I can't focus on the video anyway, so let's just switch to the book. So this is the computer science book, and let's go to the first chapter. Okay, maybe read the preface. And you can see like chapter 1, it's just introduction, like what is cognitive science and representation, then some kind of computation, I don't know what it is, and then interdisciplinary crossroads, and then it's giving an introduction to all of these approaches, and then we'll get into these approaches